Okay, this is the second video of chapter 1, and in the previous video I explained the conceptual way to understand probability, and in particular I emphasized the repetition of experiment. We have to think about repetition of experiment to understand how the probability is defined and to understand what we are looking for, what we are trying to estimate. And in this video, I'm going to briefly talk about simple data from the data how you can calculate the probability. It's super simple, and this video will be, I guess, will be pretty short. So think about example like this. Now let's think about dice. You throw dice for 200 times and you record the outcomes. So from experiment number 1 up to number 200, you record the outcomes. 1, 5, 4, 4, 2, 3. Right? So the actual record will be a super long list. Like it'll be an Excel file, for example. So this is data. And as you can see, it is not convenient to see what's going on. So if I do not explain the experiment here, you may wonder what the data are. What is the experiment and what's the outcome? And it's hard to see what's going on in this experiment. So we need to summarize the data. The simplest way to summarize the data is change the table with 200 rows into a simple 6-row table. Here, what I do here is count how many ones and how many twos are in the data. And out of 200 experiments, you observed 1 in 33 outcomes, and 2 happened 31 times, and 4 happened the most, 41 times, and 5 happened only 28 times. Like that, it gives you the frequency, right? So frequency is the number of occurrence for each outcome, count of each outcome, and the sample size again is the total number of the experiments, which should be equal to the sum of all frequencies, right? Because there are 6 possible outcomes, there are 6 frequencies you calculated, and some of them must equal to the total number of experiments, obviously, right? So this is a simple summary. You change it 200 numbers into 6 numbers. So it's a very efficient way to present the data, right? And one step further, you calculate the probability based on the frequency by dividing them by the total number of experiments, the sample size. So that means I said 1 happened 33 times out of 200. So 33 out of 200 is its probability, which is 16.5%. Right? So in that way, you can calculate 6 different probabilities for 6 possible outcomes. As you know, the sum should be 100%, right? 100%. This is the probability Maybe I believe you know this without further explanation. And then, just in case, if you are not familiar with this idea, try this question. In this data, what is the probability of getting an even number? So, by the way, what I wanted to say here is this is another summary of the data. So probability is the main purpose of probability is to summarize the data. You cannot give 200 numbers. Instead, like simply present 6 numbers, and that will be enough to calculate, to understand the experiment, the randomness. And let's see what we can do with this summary. From this information, try to calculate this probability. Right? You may use a calculator. It doesn't matter. You may use Computer Excel. And throughout the semester, I'm going to give you questions like this, some algebra questions like this, so that you can practice simple math and to follow, to check if you're following what I'm explaining, what I'm doing here. And if you are confident you know how to do it, you may skip that. Or if you take more time, then please stop the video and do your work, and then resume when you finished your work. Okay, so the probability of even number, we are interested in the even number, then you can calculate that probability by considering these 3 probabilities. 1, 2, 3. And sum their probabilities. So out of 6 possible outcomes, 3 outcomes are even numbers. So sum their probabilities and you get 53.5%, right? And again, you may wonder, by the way, you may wonder why it is not 50%. So you know the true probability, because even number should be 50% from a dice. That is true probability, but what we are calculating here is probability from the data. From 200 repetitions, which is a small number compared to the infinity. So the true probability, you know, like true probability 50% is based on infinite number of dice. But what you have is only 200 observations. So the difference is the error coming from the finite number of observations, because so error that happens because you could not do an infinite experiment, right? So that is the probability. And by the way, before talking more about the probability, also I would like to emphasize this at once, and like now. So we are going to use percent for as if it's a unit for probability, but you know it doesn't need be a probabilities unit. Like say interest rate, inflation rate are calculated in percent point, right? Percentage. So it doesn't need be a probabilities unit, but and also what I want to say here is you can understand 20% as a number. It is a number. It is 0.2. So 20% equals 0.2 equals 2 over 10, right? Pretty simple. But the reason why I'm telling you this is because using the percentage unit is confusing, especially when you need to calculate something else. For example, 20% times 30% is not 600%. So this is a typical mistake. Happens because we use percentage as a unit. You have to calculate this as 0.2 times 0.3. These are numbers again, numbers. So transform them into numbers and then calculate multiplication, and then if you want, reconvert the result to percentage. So the answer should be 6%, not 600%. So be careful. And in the lecture and in the homework, I may switch between these guys without saying anything because they are equal. So when I switch between 0.2 and 2 over 10, it's obvious they are the same thing. Like that, 20% is exactly the same thing as 0.2. There is no difference. So I may just switch between them in my algebra. So don't be confused. And I'm not going to talk about this anymore, right? So coming back to probability. So coming back to the probability, in our example, we calculated probability for even numbers, right? Not just a single outcome. That's so. We call an event. So event is different from outcome. Probability can be defined for a single outcome or for multiple outcomes, like this example. You can define probability for like even numbers, or like say, for example, numbers greater than 3, for example. So any group of outcomes can be assigned some kind of probability. So we distinguish outcome and event like more rigorously to rigorous argument to state the probability in a more rigorous way. Probability is defined for any event. An event is a collection of set of outcomes so that a probability can be defined. And an event probability can be defined as the sum of probabilities of outcomes included in that event. So outcome is a element of an event. And when you define probability for an event, you need to you can look at the probability for each of the single outcomes in the event. So for example, then the difference between event and outcome is that single outcome is an event. You can define an event as one outcome. So one outcome makes one event. Like we can define probability of 1 or probability of 6. And as you see, any set of multiple outcomes can be an event, right? And an event may not include any possible outcomes. This is also possible. Conceptually, you can define probability, like for example, from a dice, what is the probability that you get 0? Its probability is 0. Just you can define probability for an impossible outcome. Its probability is 0. It's well defined, right? And you may think of an event that include all possible outcomes. So what is the probability to get a number between 1 and 6? 100%. So it is so by defining event that is distinguished from an outcome, you can generalize the probability to any kind of event, any kind of things. Like so, it extends the concept of probability even further by considering multiple outcomes or impossible outcomes or all outcomes. So this is important mathematically to distinguish the outcome and event to prevent confusion. Okay, so I'm going to stop here and we will start a more complicated, more difficult cases with real data in the next video. See you later.